Now, picking up where we left off in the last video, in the previous video we derived these three expressions, and now using these three expressions we are now ready to derive the transmission coefficient. So recall that the transmission coefficient is equal to the absolute value square of f divided by a. And you can see that in this expression we have a over here, and then we have c and d, and then you can see that we can actually substitute in c and d with these two expressions, and then we will have an expression that relates a and f, and then all we have to do is to divide f with a and then take the square, and that will give us the transmission coefficient. So all we have to do now is to substitute in these two expressions into c and d, and so this is what we'll do. And so if you do that, starting off with the left hand side, we have 2a e to the power of negative ika, and we know that this is equal to, first of all we will substitute in this expression. So first of all we have a f, and then we have 1 minus il divided by k, and then we also have this expression 1 plus ik divided by l, so we have substituted in this expression, and then we also have an e to the power of ika, and then we also have two of these e to the power of negative LA's, so we have e to the power of negative 2LA, because we have two of them, they just multiply together, and then divided by 2. So this is the first expression, and then for the second expression we just do the same thing. So for the d we just substitute in this expression, so we also have, so instead of d we have f, and then 1 minus ik divided by l, and then we also have 1 plus ik il divided by k, and then we also have this e to the power of ika term, and then after that we have two of these e to the power of la terms, so e to the power of 2la, and then finally divided by 2. And so now we have this expression that relates a and f, and so all we have to do now is to simplify this expression. So what follows is just some very tedious and long algebra. So continuing with the expression that we have just derived, I'm now going to focus on this expression, and then I'll try to simplify it. So the first thing I'm going to do is to pull out some of the terms. So this left hand side is equal to this right hand side expression that I'm trying to simplify. So I'll just pull out a f, I'll pull out the e to the power of ika, and I'll also pull out the 2's. So all we're left with is e to f times e to the power of ika divided by 2. And so once you pull these terms out, what you have left inside the bracket is 1 minus il divided by k. So at this point this is just a bit of copying work, so let's just copy these expressions down. So 1 plus ik divided by l, and then we have e to the power of negative 2la, and then we do the same thing for this other expression. So these terms have been taken out, so all we're left with is 1 plus il divided by k, and then 1 minus ik divided by l, and then times e to the power of 2la. And so now let's try to simplify this expression a bit. So let's just copy this down, and then simplifying this expression, let's just take about this bracket. So in the end we're left with 1 minus il divided by k, and then we have plus ik divided by l. That's just this expression times 1. And then also when these two expressions multiply, you can see that the l's cancel out, the k's cancel out, and then we have an I square. So these two i's multiply together. And the I square is negative 1, but we also have a negative sign. So we just have negative 1 times negative 1, which is just positive 1. And so this is what we have for this expression. And then we do the exact same thing over here. So we have 1, and then plus il divided by k, and then also minus ik divided by l. And then when these two expressions multiply, the l's cancel out, the k's also cancel out. We have a negative I square, which is just equal to 1. And then e to the power of 2la. And so now I'm going to group together some of the similar looking terms. So right here we have 2, so we have 1 plus 1, so we have 2 inside this bracket, and we also have a 2 inside this bracket. There's also a 1 plus 1. So we have 2 times e to the power of 2la plus e to the power of negative 2la. So I'm just grouping together the terms with the 2, And then for the remaining terms, I'm going to group them up like this. So I'm going to pull out the I. You can see that for the remaining terms, they all have I. So I'm just going to pull out the I. And then here we have LK minus L divided by K minus K divided by L. And then you can see that here it's the exact reverse. So here we have positive L divided by K. And here we have minus L divided by K. So if I pull this expression out, we first of all have e to the power of 2LA. But then for this term, we need to subtract e to the power of negative 2LA. Because you can see that the signs are reversed in this expression. So here we have positive L divided by K, here we have negative L divided by K, and here we have negative K divided by L, and here we have positive K divided by L. So if I pull this expression out, I need to give back a negative sign to the e to the power of negative 2LA. And so this is what we have so far. And to simplify these two expressions, we can now introduce the hyperbolic sine and cosine terms. So recall that the hyperbolic cosine is defined as e to the power of x plus e to the power of negative x divided by 2, and the hyperbolic sine is defined as e to the power of x minus e to the power of negative x divided by 2. So using these hyperbolic sine and cosine functions, we can now simplify these two expressions. So moving on with our simplification, let's just copy these terms down first. And so we have these two expressions here, and you can see that for this first expression, this looks like the hyperbolic cosine term multiplied by 2, because there's no divided by 2 here. So this expression just becomes 4 hyperbolic cosine 2LA. So remember there's an extra 2 over here, so these 2's just multiply together, so you get a 4. And then we do the same thing over here. So we have I, and then let's just combine these two terms. So we have L squared minus K squared divided by LK. And then for this term, this resembles the hyperbolic sine term with the 2 multiplied to the other side. So what we have here is 2 hyperbolic sine 2LA. And so there we have it. And now to further simplify this a little, I'm going to pull out the 4 from inside the bracket. So this just becomes 2f e to the power of IKA. So the 4 simplifies with the 2 in the denominator. And then since I've pulled out the 2, this just becomes hyperbolic cosine 2LA. And then this becomes L squared minus K squared divided by 2LK. So I need to put an extra 2 in the denominator because this is not equal to 4. So if I pull out a 4, I need to give back a 2 in the denominator. And then we have hyperbolic sine 2LA. And recall that this entire expression, we've been simplifying this expression this whole time. This entire expression on the right-hand side is just equal to this expression on the left-hand side. So recall that this entire expression is just equal to 2a times e to the power of negative IKA. And don't forget, our ultimate goal is to find the transmission coefficient, which is just equal to f divided by a absolute value squared. So all we have to do now is to divide a to the other side, and then to divide this expression to the other side, and then to square it, and that will give us the transmission coefficient. But it seems a bit annoying to have to move this expression to the other side, so instead of looking for the transmission coefficient, I'm going to derive the transmission coefficient inverse. So that will give me the absolute value of a divided by f squared. So finding this is just the same thing as finding this, but finding this is slightly simpler because I don't have to move this term to the other side. So we'll settle with finding the transmission coefficient inverse. So let's just look for a divided by f absolute value squared. So now I need to divide f to the other side, and then I need to divide 2 over to the other side, and then we have e to the power of 2IKA, so moving this over to the right-hand side. And then we also have this cosine and sine term, so I'll just spare myself some time. So these squiggly lines is just this entire expression. So a divided by f is equal to this e term multiplied by this expression. And so now, in order to find the transmission coefficient inverse, all we have to do is to take the absolute value and then to square this expression. So now the transmission coefficient inverse is just equal to the absolute value of a divided by f squared, which is just equal to the absolute value of this term, but the absolute value of this e term is just equal to 1. So the absolute value square of this e term is just equal to 1. because if you have a complex number and you take the absolute value square, this is just equal to the complex number times its conjugate. And then if you have this e term, if you multiply it by its conjugate, ika, if you multiply it by its conjugate, this is just equal to e to the power of negative 2 ika. So these two terms just cancel out. It just gives you e to the power of 0, which is just equal to 1. So this term is just equal to 1. So if you take the absolute value square, this e term is just equal to 1. And then we also need to take the absolute value square of this expression. And you can see that for this expression, there is a real term and there is an imaginary term. And if we have a complex number, a plus bi, if you take the absolute value square, this is just equal to a squared plus b squared. And you can easily prove this by multiplying a plus bi with its conjugate, a minus bi. So using this a squared plus b squared formula, we know that the absolute value square of this entire expression is just equal to the square of this term, the real term, and the square of this term, the imaginary term. So all we're left with is hyperbolic cosine squared 2la, and then plus the square of this term. So L squared minus K squared divided by 2LK whole square, and then sine, hyperbolic sine squared 2LA. And so this is the expression that we're left with. And then we can further simplify this a little bit by considering the identity hyperbolic cosine square of x is just equal to 1 plus hyperbolic sine square of x. And you can easily prove this by going back to the definitions. So you can take these two expressions, you can try to square them, you can see that this expression is always true. So moving on, so we know that this expression is just equal to 1, so we only have to deal with this. And then the cosine term just becomes 1 plus the hyperbolic sine term. So that just becomes 1 plus L squared minus K squared divided by 2LK whole square times hyperbolic sine squared 2LA. And so there we have it. So in a sense, you can say that we are done. This is the inverse of the transmission coefficient. So if you want the transmission coefficient itself, you can just do 1 over this entire expression. But we can actually do even better. We can simplify this expression further by considering L and K, because don't forget L and K are just shorthands for the expression 2m v minus e divided by h bar, and the K is just a shorthand for 2me divided by h bar. And so we want to express our final answer in terms of v and e and mass and all the constants that we were given. So what we're going to do is, instead of expressing our answer in terms of L and K, we can substitute in these two expressions to further simplify this expression. So let's do that as well. And so moving on, we'll focus on the L squared minus K squared divided by 2LK expression. And then we're going to substitute in their definitions. So L squared just becomes 2m v naught minus e divided by h bar square. K squared just becomes 2me divided by h bar square. And the denominator just becomes 2 multiplied by 2m v naught minus e divided by h bar. And then 2m e divided by h bar. And you can see that already that some of the terms, they cancel out, so we have an h bar square in the denominator, so obviously these cancel out, which is always a good thing. And then you can see that, so let's just rewrite this expression like this first. So we have a 2, and then both of these terms there's a 2m, so we also have a 2m, so you can see that that also cancels out with the term in the numerator. And then we also have a square root of e times v naught minus e. And so now cancelling these two terms, we're left with v naught minus 2e in the numerator, and the denominator we have 2 times the square root of e times v naught minus e. And we can further simplify this expression, because don't forget we need to square the entire expression, so this is just the inside term, so we also need to square the whole thing. So squaring the entire expression, we have v naught minus 2e whole squared divided by 4e v naught minus e. And then don't forget, for this entire expression there is also a 1 plus. So let's just also add a 1 plus. And so adding a 1 plus, I can combine these two terms together. So in the denominator we have v0 squared minus 4v0 e plus 4e squared. I'm just breaking apart the square here for this expression. And then if we plus 1, then we have plus 4e v0 minus e. And this entire thing divided by 4e v0 minus e. And then here you can see that the terms also cancel out. So we have a 4e squared, and then here we have a minus 4e squared. So these cancel out. And then here we have a positive 4e v0. Here we have a minus 4e v0. So they also cancel out, which is always a good sign. So everything here cancels out. So all we're left with is v0 squared divided by 4e v0 minus e. And essentially now we're done. So taking this expression, we can now substitute it back into this expression. So let's just write out the final answer one last time. So the transmission coefficient inverse is just equal to 1 plus. So we have 1 plus this entire expression, which we have just found to be equal to v0 squared divided by 4e v0 minus e, and then multiplied by the hyperbolic sine function squared. So the hyperbolic sine function squared. And then don't forget this is 2LA, so instead of writing L, I can also substitute in back the definition of L, which is just this expression. So let's do that as well. So we're left with 2a square root of 2m v0 minus e divided by h bar. And so there we have it. This is the answer that we're after. And so after all this algebra and all the simplification, we have finally reached our answer.